This is definitely not easy integral. Here I would like to show my own method. Well, maybe it's original because I haven't seen anybody did it. Now I start with the indefinite integral e to the negative tangent to square x dx to the antiderivative of this function. Because this is exponential, therefore its antiderivative must contain the same exponential function and multiply another function, say called f of x, negative tangent to square x, and plus c. Okay. Then I differentiate both sides with respect to x. Now, the right-hand side use product rule. So f prime of x times e to the negative tangent to square x, and plus f derivative times this. No, f of x times this derivative, which is this derivative, right? This is e to the negative multiplied by the derivative of negative x tangent square x, which is equal to negative 2 times the tangent x and the secant x square, right? Yeah. And it is equal to this derivative with respect to x, that is e to the negative tangent square x. So then I cancel the common factor. I get f of f prime of x is equal to 1 plus 2 tangent x secant square x. Well, I call this one star equation. Now, if we find f if we find f of x from this differential equation, then we find this integral. Then we find that one, right? But we cannot use the regular way of finding differential equations. Solve different differential equations first order using integrating factor, because this is the integrating factor. And then you go back to this one. So therefore it doesn't work. So what I'm doing here is that from this observation, I try to propose what f prime of x is, will be, rather. So I know that when x equal to 0, this tangent x is equal to 0. This is not a 0. If this is 0, then this is 0. So therefore, f prime of x is equal to 1. And f prime of x, when x approaches to half pi, say from this interval, is from the left-hand side, then tangent half pi is infinity. This is infinity. Therefore, the whole thing is infinity. And based on these two, I just suppose that I guess f prime of x is equal to kx over half pi minus x plus 1. This one satisfies this one. This one satisfies this. See, this is method of approximation. So I just presume that f of x is equal to this. So this is approximation anyhow. Okay, then I can find the f of x is the integral of kx half pi minus x plus 1 dx. While I don't spend time for this one, I think this post is not a difficult integral. So this one is equal to negative kx minus k pi over 2 and log half pi minus x and plus x and plus c. So this is my f of x. I assume this is my f of x, at least to satisfy these two conditions, and which is reflect to this equation. Now then, I want to find the k and the c. If I want to find the k and the c, I need two simultaneous equations. So I have to create two simultaneous equations, and from here, right, if I assume two numbers, say x equal to 1/3 pi, then then my f prime over 3rd pi, you plug this one here, then this one is equal to 2k plus 1. Okay. Then as also I plug 1/4 pi, then this one is equal to, I calculate this one equal to k plus 1. And I needed two equations. Then f over 1/3 pi, this is f of x, right? This is f of x. So this is equal to negative k pi over 3 minus k pi over 2 log pi over 6 plus pi over 3 plus c. Okay. From this one, I get f of, then I get f of 1/4 pi. I plug the value x as 1/4 pi. Then I have a minus k pi over 4 minus k pi over 2 times log 1/4 pi plus 1/4 pi plus c. Right? Yeah, I needed two simultaneous equations. See, the first one, I put the x equal to 3rd pi into this star equation. Then I get the star will have a 2k plus 1, right, is equal to 1 plus, I plug the value 1/3 pi here and there times 2, it becomes 8 root 3 multiplied by f of x, which is minus k pi over 3 minus k pi over 2 log pi plus pi over 3 plus c. Okay, then I can simplify by canceling 1. Therefore, this is 2k is equal to 8 root 3 minus k pi over 3 minus k pi over 2 log pi over 6 plus pi over 3 plus c. I call this equation 1. Now then I plug x equal to quarter pi, then my star will will uh, will be f prime of a quarter pi. F prime of a quarter pi is k plus 1. K plus 1 is equal to 1 plus twice this times this. The quarter pi tangent x is equal to 1. This is equal to 2. Therefore, becomes a 4 times f of quarter pi. F of quarter pi is this. So minus k x pi over 3 minus k pi over 2 log quarter pi and plus quarter pi plus c, right? And I simplify by canceling 1. So k is equal to 4 times negative k pi over 2 log quarter pi plus quarter pi plus c. I call this equation 2. Then see, I have a 2 simultaneous equation, so I can have a k and a c after solving them. Now, see, well, I'll use this notation. 1 and a 2, I get a solution for k equal to negative 0.5 4 4 5, and this c is equal to negative 1.1426. Well, I'm using computer to find these solutions, and maybe there's some errors somewhere, but anyhow, I want to show the method. Now, then my f of x is found. So my f of x is this, right? And plug k there. Yeah. Well, my f of x is equal to negative 0.5445 x. And minus, it becomes plus 2, 5, 4, 4, 5 pi times the log half pi minus x and a plus x and a plus c. C is negative 1.1426. So this is my f of x. Now we can come back to the I, which is my target integral, e to the negative square x dx, which is equal to f of x times exponential, right, from 0 to, and tangent half pi is infinity, so this is equal to 0. Minus, when tangent when x equal to 0 is equal to 0. So they equal to 1, and the 1 times f of a 0. Yeah. So this is equal to, we just put x equal to 0 there. So this is 0, 2, 0.5445 pi log pi, right? Because x equal to 0 plus 0 minus 1.1426. Negative. Forget negative. Negative, huh? Negative, sorry. So negative, that was, so this equal to, finally the answer is a 0.75636. So this is my approximation answer. Now from the computer, the answer is 0.67165. I think this is quite close. It's a reasonable approximation. See, but see, I'm using total different methods. See, the method may be not accurate. The method is tedious. It's not perfect, but it's a method. It's one method. I hope with this method, I did it in well, I never see anybody did it this way. I hope with this method is original.